All right, we're going to look at an introduction to rational functions. All right. So a rational function is when you have a polynomial over a polynomial. You got two polynomial functions. So something like 3x minus 5 over x squared minus 6x minus 7. That would be an example of a rational function. Um, and one of the things we're going to look at here is we're going to look at the domain of rational functions. And so domain is the allowed x values. So what x values are you allowed to use with this function? Which numbers are you allowed to plug in and calculate things? And the default assumption is all real numbers. So normally this would be all real numbers. Right? So for polynomial functions, if I said, what's the domain of the linear function 3x minus 5, it would be all real numbers. What's the domain of the quadratic function x squared minus 6x minus 7? It would all be all real numbers. But when we get to rational functions, we come in with a issue that doesn't show up when it's just a polynomial. And that is we can't divide by 0. So any x value that would make the denominator 0 has to be eliminated from the domain. It can't work. So let's say I wanted to know, let's say find the domain, find the allowed x values, find the domain, and I'm going to look at this function we were just looking at. R of x equals 3x minus 5 over x squared minus 6x minus 7. And so I run into this rule. Now that I'm looking at a fraction, I have to make sure that the denominator is not 0. So what I need to do is I need to first figure out what would make this denominator 0. What would be the numbers that would cause the problem? And so to solve this equation, I'm going to factor. Factors of 7 that are different by 6 are 7 and 1. Different signs, bigger one's negative. I'm going to set those equal to 0. And I'm going to solve them. So add 7. So 7 would make us 0 on the bottom, right? It would be 49 minus 42 minus 7. That would be 0. So that would be bad. We don't want that to happen. And negative 1 would make the bottom 0. That would make that 1 plus 6 minus 7. That would also be 0. So those two values for x would make the bottom equal 0. We don't want that to happen. So for our domain, there's two ways we could say this. We could say, I want every number less than negative 1, every number between negative 1 and 7, and every number bigger than 7. That's one way I could say the domain. Or if I want to use interval notation, I can say I go from negative infinity to negative 1, union negative 1 to 7, union 7 to 8, and I just skip over those negative 1s and 7s, right? I come right up to them, but don't quite touch them, skip over it, move up to the next one almost, skip over it, move on. But an easier way to say this, and how a lot of people will say it, is instead of saying what is allowed, which is what I'm doing on these first two, an easier way might be just to say what's not allowed. And so I might just say, if someone asked me what's the domain, I would say x cannot be the numbers negative 1 and 7. And that's how I would state the domain, as a way of saying that it can't be these numbers, but it could be anything else. And that's typically how you'll see it. But you can do it these other ways if you want to. If you want to actually list out what the things are allowed, sometimes it's easier, though, to say what's not allowed. All right. One thing we're going to run into when you first get introduced to this is situations like the following. Um, let's say you have x squared plus 10 on the bottom. And you go, okay, I have a fractional expression. I don't want it to be equal to 0 on the bottom. So I'm going to set the bottom equal to 0, and I'm going to work that out, right? I'm trying to figure out what is the domain here, right? And what I find out is I can't make this work. It doesn't factor. There aren't factors of 10 that'll add and give you 0 x's, right? There's no x's there, so there's 0 x's. There's no factors out of it. This will not factor. And in fact, if I kind of, I wouldn't do this if I wanted to factor, but just kind of show what's happening here is this is really saying I want to square something and get a negative. Well, if you take a positive and you square it, that's going to be positive. And if you take a negative and you square it, that's also going to be positive. So there are no real numbers that will make this work. There are no real problems here, real number problems here. So what's my domain in this case? My domain is all real numbers. Remember, that is where we're starting from. We're starting from the idea of all real numbers, and then we're seeing if there's any real numbers that would cause us a problem. In this situation, there aren't. There aren't any real numbers that would make this. It doesn't factor. And if we just look at it, there's no way you can plug a real number in here and get something that you could add to 10 and get 0. So this domain is all real numbers. Sometimes you run across those at the beginning with this type of introduction to rational functions.